This episode is supported by Virtual Peaker. Thanks for your support to make these discussions possible. Welcome to the next edition of Grid Forward Chats. I'm Bryce Yonker with Grid Forward. Today we are excited to have with us two leaders driving innovation forward in nuclear energy. Ben Porath is the EVP of Dairyland Power Cooperative, and Clayton Scott is the EVP of NuScale Power. Gentlemen, thanks for being on with us.
Thank you. Thank you for having me today.
Thank you.
So maybe we'll start first with you, Ben. Can you introduce yourself, your role there at the organization?
Good afternoon, Bryce. Ben Porath. I'm Executive Vice President and Chief Operating Officer at Dairyland Power Cooperative, headquartered in La Crosse, Wisconsin. I've been in the electric utility industry my whole career, just a little over 25 years now. I've come up in the system operations, reliability side of the business, really focused on transmission, system operations, making sure the grid remains reliable, which is really an important topic these days as we're heading into an energy transition away from the traditional base load, intermediate generation paradigm to the renewable energy resource paradigm.
Great. Thanks, Ben. Good to have you on. Clayton, maybe you can introduce yourself and NuScale.
Sure. Clayton Scott, Executive Vice President for NuScale. I joined NuScale just a little bit over a year ago. I came out of the nuclear industry. That's all I've been doing is just a minor 42 years of my career. So I've been involved in new builds around the world and worked in utilities and for supply chain in the industry, both Canada, US, and various other places globally. And my responsibility is business development, marketing, communications for the company, and to bring NuScale to a deployable position in the market.
Great. A few years each. I know this is necessary on something so complicated like this. We often, for our audience, don't need to define it. But Clayton, maybe I'll have you dive in first. What is a small modular nuclear reactor? Why are folks talking about them right now? Why is this something that's really active in the industry?
Well, it's a good question. It's somewhat a debatable question as well, because the size or the debate around size of small modular reactors has been kind of discussed between IAEA and other organizations. So, some have set a 300 megawatt target or less, but bottom line is they're not a typical large scale plant that you normally see in the gigawatt size in one single unit. Having said that, for NuScale, our NuScale Power Module, the MPM, is a 77 megawatt integral pressurized water reactor. It's a PWR. It's gravity-driven circulation, but it's built in that capacity. It's a complete self-contained reactor, so it includes the containment. It's fully factory-built, shipped to the plant by truck, rail, or barge. So the intention is to have a reactor that's manufacturable in a factory, that's a fabrication scale, so you're no longer doing it at site. Part of the benefit that NuScale brings is our design is somewhat unique to the other small modular reactors, is that we're not just a single module on a site. We can actually have up to 12 modules in one reactor building, which gives us flexibility from 77 megawatts up to 924 megawatts. So it allows us to have variable flexibility. Plus, it also allows the customer to ramp up as they see the need for the power.
So, Ben, I think Clayton covered a lot of the attributes of what an SMR is and what's kind of making it unique. Maybe you can talk a little bit about what's special about it. Why is Dairyland thinking about it? Why are other operators thinking about these resources?
Yeah, I think we're at an interesting time in our industry. As we are transitioning away from carbon-based resources, and if this country is really serious about reducing our carbon, which I think we are, then you need something out there that can produce the scale, dispatchability, reliability of energy we need. And that's where I think small modular reactors and nuclear comes into play. As coal units retire, natural gas is really just being talked about as a transition fuel. What are we going to really have for the long term that's going to be there, that's low carbon, no carbon, and really provides the reliability at the base load level. But I don't think a lot of the general public really realizes how much energy is really used between commercial, industrial, residential, and while solar, wind play a role, and storage is coming, distributed energy resources, the integration with those, we are going to need some base load energy out there. And I think that's where SMRs and nuclear really come into play.
Yeah. So how does the portfolio of the energy mix that you all serve fit with nuclear? I mean, I think the idea of the firm generation source is really what you're getting at there. Is that the crux of it? And is there other things in transition in your portfolio?
Yeah, definitely transitioning right now. In the Midwest, we were really a heavy coal-based part of the country. There's some good hydro in the region, but it's not right where we are. The natural gas pipelines aren't as robust as we need in this area. So we're going to need something as we continue to phase out and retire the coal. What's going to replace it? And really, we have a natural gas power plant, a combined cycle natural gas power plant in our plans. And that's going to be our next build if we can get it permitted. So we're really looking for that 10 to 15 years out. What's next as the coal plants continue to retire? We're going to be working on the DER, the innovation, but we think there's more needed, which is where the nuclear really fits in that 10 to 15 years out to really provide the firm energy.
Great. Been anything else that kind of level sets us on what small modular nuclear reactors are in the market and what's kind of creating some excitement about them, or should we jump into some other topics?
Well, I think one of the other things that's exciting right now is the federal support, right? As we're Inflation Reduction Act, some of the other federal programs that are going to help make this energy transition, whether it's looking at the distributed energy resources or things like advanced nuclear. I think we really need to take advantage of those programs to help transition the grid.
Great. So Clayton, we're just going to jump right in. I mean, we're a couple minutes into the conversation, and let's talk about cost. So
everybody's favorite subject, yeah.
I know I don't need the intimate nitty gritty details, but there's a lot of talk, maybe some confusion. Can you share a little bit about where the evolution of this market is and cost now versus cost in the future? What should we be anticipating for the sort of competitive nature of this resource?
Yeah, I mean, I think, there's a lot of elements around cost, and it goes various from design to design because not every design is the same. But when you do look at some of the costs that some of the, SMR companies have put forward, and when you look at where we think we can benefit, I mean, I think some of the key elements are clearly around licensing. And, the licensing cost, that's something that, NuScale has certainly put a significant effort in. We're the only SMR to be certified by the US NRC, and that was not an insignificant effort. I mean, the cost to get certified is, it was circa $300 million to get certification, plus the amount of effort and time to get to the R&D effort to get to that point in the first place. I mean, I think NuScale, over the course of its inception, has put in close to $1.4 billion in research and development. So getting a technology to a point where it's certifiable is something that I think people need to really evaluate and understand, because it's not something you can bypass. In order to be an operational plant, you have to get certification, whether you do it through a Part 50 or a Part 52 process. At the end of the day, you still need to be certified. So I think that's one element. I think the bigger thing is that we have to understand where this dynamic is going with the manufacturing and with the plant build in the balance of plant. I mean, if you look at all the large scale projects that have been challenging globally, Okilotto, Hinkley Point, Vogtle, et cetera, these are very large scale projects that have been in a design element phase or a design change phase during that construction period, which has big impacts or potential big impacts. What we're seeing here is the being able to take and build a factory and actually put the reactor through a factory that's in a consistent, qualified process, like assembling a car, then that we expect that is the driving element of your reactor costs to get down to an nth of a kind cost. And I think various suppliers will have different numbers of what they consider nth of a kind, but I think in some short order, less than 10 modules or 10 reactors, that supply chain will probably consider it to be an nth of a kind to the benefit of future buyers. Now, I think what we're also looking at is we're also trying to modularize as many of the components and building structures that go into the site build itself outside of the reactor in parallel. So I think over time, if we can figure out how to put as many things through a factory and try to minimize the concrete and the rebar and the standard construction to a minimal and get that to a really efficient project management construction perspective, then I think we start seeing true cost of what the SMR build is compared to a traditional build. I mean, we're still looking at a $45 to $65 per megawatt hour position, but a lot of that has to do on labor rates, has to do on siting and owner's cost and inflation, interest rates. There's a lot of contributing factors that go into that number.
Great. Ben, I know cost is obviously a consideration for the members and the community there. When you all look at these, what's kind of on your radar on that from that standpoint?
Yeah, you're absolutely correct. As a rural electric cooperative, cost matters. What the member consumer at the end of the line is really concerned about costs. So as we're working with NuScale, investigating their technology, we're looking at several things. One, we're a relatively small utility at just over 1,000 megawatts of peak load. What we're really going to need to do is find some partners if we're going to pursue one of these plants, where maybe one of the larger utilities in the region is the operator. We're taking a share of this plant. We're spreading the costs over a little larger footprint with an investor-owned, maybe some municipal utilities. So that's one thing we're looking at. The other thing we're looking at, I mentioned before, is the federal funding opportunities for the early adopters of this technology. There is federal funding out there that's going to help buy down the cost. So that's for sure something that we will be looking into as we continue to pursue this. And really, the third thing we're watching out there is a project underway right now out in Idaho/Utah, the UAMPS project. I think the whole industry is watching that. And so that's going to get the scale. If that plant goes forward successfully, gets online, we're all going to be watching that and looking to be potentially one of the next few plants in line.
Clayton, anything to add on the federal resources that are in motion and the sort of impact those may have in the near and midterm?
No, I think I think it's a bipartisan position. I think the interest is obviously strong. We certainly benefited from the earlier programs, and I think some of the new competitive programs, both in the DoD space and in the commercial space, is benefiting the new Gen 4 reactors as well. So no, I think the timing and the climate is right and supportive within the administrations and the government to push forward on nuclear. And I just hope it continues, which I think it will, because I think we're all realizing that it's not just carbon-free power we need. It's 24/7 carbon-free, but also it's energy security issues. I mean, so there's a lot of importance to this. So I think I think the continued support from the government will be strong.
So when I think about nuclear, and I suspect a lot of others think similarly, safety comes top of mind. So Ben, maybe I'll kick it to you first, and then to you, Clayton. When you all are thinking about adopting some nuclear resources, is this a concern of your community? Is this a paradigm shift with SMRs versus traditional nuclear, or what's similar or different from your standpoint with regards to safety and nuclear energy resources?
Well, I think as a rural electric cooperative nonprofit, about the member consumers we serve out there, health and safety is always top of mind for us, whether it's operating electric grid components, making sure folks are safe from electrical shock, having high quality lines, substations out there. So definitely top of mind for us. If you've been in the industry a long time, and I know folks have been a lot longer than I have, and Clayton obviously knows a lot more than I do, but one of the things I've observed in my career is nuclear is a lightning rod topic, but it's more of a sensationalization topic by the media than actual real risk or danger, in my opinion. So one of the things we would do as we continue to pursue looking at developing this is we'd be getting out and talking to the local communities where we might potentially site one of these plants to get the feel of the community, talk to them, educate, explain, talk about some of those more highly covered events around the world over the years and what the facts were versus the hype that was in the media. So we believe it's a safe technology. We know it's a safe technology, right? There's years and years of operating experience that tell us that. So it's a matter of just getting out and educating the populations, especially around where we might site a plant.
Great. Clayton, from your perspective, is this a step change? Is this a paradigm shift? What is SMRs versus traditional nuclear? And is it a different way of thinking about nuclear with regards to safety?
Yeah, I mean, I certainly think it's a step change. I mean, I'll obviously, NuScale, I think, has done some very significant, first of a kind changes in relation to safety. The design, the benefit is, it's, as Ben stated, it's based off of 60 years of PWR light water technology. But, we're a first in many cases. We offer a triple crown safety, which is, our reactors can shut down, they can self-cool indefinitely, they can do so without the need of an operator or computer action. We don't need any AC or DC power, off-site power. We don't need any addition for water. There's a lot of different aspects in it that we as a design are far different than a traditional design. The majority of the safety systems required in a large-scale design have been eliminated in our design. So, and it's not eliminated from it's just not required. I mean, for us, we don't have any reactor coolant pumps. I mean, there's a lot of different elements in the reactor design that is extremely safe. It's really a passive walk-away safe reactor. And that's the fundamental difference. And I think, ultimately that will change the dynamic. And to the community perspective, a traditional reactor requires a 10-mile radius for an emergency planning zone. And NuScale is the only reactor technology that their emergency planning zone methodology has actually received an NRC ruling to maintain it at boundary. So our site boundary, for example, at 60 acres, I mean, we can basically put this very close to a community without any concern past that boundary. That is a significant difference from a community perspective.
Ben, so it seems like there's always something going on to disrupt our energy system, but I know the Midwest has been hit really hard recently with some devastating storms. I think you all are buckling up for some big spring storms around the corner. It seems that the frequency and impact of these disruptions, they just seem to be accelerating and coming at us all the time. When you think about running a resilient energy system, how does the role of SMRs, as you look to the future, how does that play into the decision making that you all are thinking through?
Yeah, very good question. When you're talking resiliency, there's obviously the poles and wires side of it, transmission lines, distribution lines, ice storms, wind storms. That's one aspect of resiliency. When we're thinking about SMRs and nuclear, we're really thinking about the resource planning side of resiliency. We're part of something called the Mid-Continent Independent System Operator, or MISO. It's an RTO ISO in the Midwest here that runs the electric grid. Within the last couple of years, because of the retirement of a lot of other power plants, baseload coal, nuclear, we're actually getting to a point where we are limited and short on available generation in certain seasons. MISO actually declared we were 1,000 megawatts short in the Midwest across the larger grid from a capacity standpoint. And the pace of retirement of power plants isn't slowing down. Solar and wind can only be added so fast. Building new high voltage transmission lines to allow more solar and wind on the grid takes time, takes a decade or more at times. So when we're talking about resilience of the grid from a resource planning side, having the energy, the dispatchable energy we need, the firm energy we need, that's where the nuclear piece comes in and the small modular reactors come in to really ensure grid resiliency over the next 10, 15, 20 years.
Great. Clayton, any thoughts from you with regards to grid resiliency and the role of SMRs?
Yeah, well, I think there's a significant amount, and again, it's somewhat specific to the design of the SMR. For example, I mean, NuScale, we have this, we've done a bunch of groundbreaking efforts around resiliency, and some of them are like black start capabilities. So we can basically start up from a cold condition without any external grid connections. So this is a first of a kind. No current nuclear plant can do this. We also have an island mode power, which is a single SMR can supply all the electricity needs to the plant, like a house load. So while also continuing to provide power to the mission critical facility without external grid connection via, a microgrid connection. We have significant resilience to natural events. I mean, we're seismically designed to 0.5 Gs, which is higher than most, and we are below grade. Pool and reactors are below grade, so from a seismic or from an electromagnetic pulse perspective, we're kind of protected. And the other thing I think is very unique is that if we have a catastrophic loss of grid and transportation infrastructure, for example, we can take a 12 module Voyager NuScale plant and we can provide 154 megawatts of electricity for 12 years to the microgrid of a mission critical facility without needing any new fuel brought into the site, making it, invulnerable to transportation infrastructure breakdowns. So this plant can be designed and placed in very unique placements and can be supportive in very challenging conditions. And it also has the flexibility of doing load transitions, et cetera. So no, the design is far different than what you see in the typical reactor designs today.
And now a quick word from our sponsor. Virtual Peaker is a cloud-based distributed energy platform that empowers modern utilities to build the grid of the future and meet global decarbonization goals. This SaaS company's platform suites unify all aspects of DER management, from DERMS to customer engagement and demand forecasting. For more information, visit www.virtual-peaker.com and follow the company on LinkedIn and Twitter. And now, back to our chat.
Ben, this kind of gets to a topic I wanted to cover as well, kind of around the wider grid flexibility topic. It's hard to call any part of an energy system a silver bullet, right? Everything needs to come together and work well. But it seems like everybody's system just needs more flexibility. What are you all looking to SMRs with that regard? What else is adjacent to that as you think about other solutions that can allow you to run a system to, match supply and demand in real time and be able to address the unforeseen impacts that are coming at us?
Yeah, in the co-op world, and definitely Dairyland supports, it's kind of the all of the above approach to power supply, energy resources. And when you say all of the above in a traditional sense, you mean different fuel types and large and small power plants. I think as we're going out into the future, 5, 10, 15, 20 years, when we say all of the above, we mean different fuels and power plants, nuclear being one of them and SMRs, but you also mean really trying to utilize the small or the distributed energy resources out there. Things that sound simple to the general public, like vehicle to grid, right? We're going to have all these electric vehicles out there. We're going to have all these rolling batteries. So, we'll simply charge when there's an excess energy, when the sun is shining, the wind is blowing. We're going to charge all these vehicles. And then if the sun stops shining, the wind stops blowing, we're going to have all these electric vehicles and batteries that we can then potentially draw from. But if you start trying to solve that problem of mobile batteries and where they're plugged in, if they're plugged in, whose system they're plugged into, how you solve all those transactions, it's a very difficult problem to solve. I think we're going to do it. We just need time to do it. Very smart people working in this industry, some really good software vendors out there. So we're looking at all those. We're looking at the SMR technology for 10, 15 years out. But we're also working on the distributed energy resource, the control of the grid through demand response, more small solar, batteries. But those are not simple problems, and the grid is so important. It's so important to everyday life that we have to get these solutions right, and we have to make sure they work. And that's where things like natural gas power plants as a transition fuel, future of small modular reactors, we know that's going to work. And we're going to have to then also solve the problem of the DER at the same time. So we just need time.
Clayton, anything else on flexibility, or can I take us to another topic?
No, just a quick thing. I mean, I do think we offer the fact that we can load follow quite quickly, which I think allows us to be part of that overall mix comfortably and to, inject when it needs to be supported. So, the benefit of having, small capacity on each module and either being able to go, steam dump to air or being able to move 77 megawatts in a quick time frame, allows us to, I think, support the grid movements that utilities looking for.
I mean, that's a good point, because when people think of nuclear, they do not think about flexible, right? You think about a gigawatt coming in immediately. We need to use it all, but that's a major change with SMRs. And are you doing that in 77 megawatt increments, or is there even more flexibility beyond that?
Well, we could. I mean, each module is managed at 77, but we could take a multiple of modules and follow them on the grid. It basically all depends on what they call in and want to adjust. So if we have 924 megawatts from a 12 module plant and they want to manipulate 280, well, we can do so by moving, which corresponding module makes sense. But yes, we have the flexibility. Yeah.
Great. Let's talk a little bit about energy transition with regards to communities. So there's a lot of, Ben, you've been talking about it a couple times. There's a lot of transition with regards to traditional infrastructure coming offline, but that has a major impact to those, the employee base and the communities that are working there. Ben, maybe I can talk a bit about it to you. I know it's still down the road for your organization, but with regards to putting a SMR in, do you think that's close to a one-to-one replacement, or is there a really different sort of a skill set that would be required to train up a talent base that would be working on these assets as they come into the system for you all?
Yeah, I think it's a mix, right? So I know the federal government's incentivizing, the industry's looking at taking the existing coal sites as you're planning to retire a coal plant, transitioning potentially to an SMR or nuclear. And I think we fully support that. We had two main coal plant sites in our territory. We've already retired one of those, but the next plant's got a number of years of life left. So part of our next steps with the SMR is a siting study to look at those potential sites, those old coal sites where the transmission already exists, the transmission line's already there. The communities are supporting utility operations. People know how to operate a power plant. At some point or some extent, SMR is a steam plant. So we have folks that know how to run a steam plant because they run a coal plant. It's the splitting of the atom and the system operations, but we don't necessarily have that skill set from a SMR, but there are other utilities in this region that have that skill set. We would look to a partner like a NuScale to help train folks up to do that. So we think those existing coal site communities are a good place to do this.
Clayton, any thoughts on this topic?
No, it's the thing that's beneficial, I think, is, if you look at solar and wind and some of those other renewables, they don't bring a lot of resources, right? I mean, it's a lot of land use, it's a lot of acreage consumption, but not a lot of manpower. Whereas, we come in and transition a coal plant, we're pretty much transitioning the majority of the people at the site, as Ben stated. I mean, our staffing is 160 to 260 people per site, and we're licensed to operate with 3 control room operators, but if you look at the majority of the staff in the plant, it's pretty similar to staff in a coal facility. So we can retrain, and then obviously we'll have to qualify reactor operators accordingly. But yeah, it's a good for the community because it's keeping jobs, it's bringing in jobs, and not only that, generally they're higher paying jobs. So it's a win-win.
Great. Well, let's just wrap up with a couple last topics here. And I think you did cover this a little bit, but we talk a lot about the talent pipeline in our community because there's so much in transition to advance the grid. What do you all think is necessary to bring, a diverse and qualified talent pool to scale this solution in the near term? Does anything come to mind that can really draw and attract and help meet the day for the need from a talent perspective? I'll kick it over to you first, Clayton.
Well, I think I would say it's less nuclear talent than what's anticipated, and that's probably a strange thing to say, but from a plant perspective, it's a smaller version, so it's a scaled down version. But at the end of the day, a lot of the manufacturing is done outside the site. Site's more operational, so yeah, you're going to have the day-to-day operational from the nuclear physics and nuclear asset side, and then the balance of plant side. But no, I really think if I look at the communities, seems that university programs are starting to come back on the nuclear side. There seems to be a new interest. I sit on a couple of advisory boards of a couple of different universities that have both undergrad and grad programs, and it seems that the sign up is increasing. I think the younger population are a little bit more pro nuclear than in the past. So we start seeing a movement, which is positive. But I do think people are expecting to see small modular reactors to be the new filler of the space, if you should call it. And I think they think it's exciting. I think it's an opportunity. When you look at the new designs, the control rooms are far advanced. The technology methodologies on manufacturing are advanced, et cetera. So no, I think it's a change. It's not the typical historical history we saw in the industry, but I think I certainly see a trend. Now, outside the United States, it's even more so because the building programs in nuclear have been much stronger. So there's a stronger interest, but I do see it increasing substantially in the U.S.
Anything on your side to find talent, whether it's specific to doing this potential future project or just in general there at the utility?
Yeah, that's a good question. Again, if we do this transition right from the existing coal plants or other base load firm energy plants that are out there, we're going to be able to draw on that workforce. In the Midwest here, strong work ethic, folks that really want to work and can operate these plants, right? And we made the transition to coal years ago in the Wisconsin here, at least in the Midwest. We got a lot of folks out of the paper industry. As the paper industry was going down, we brought them over and they were running the boilers and the coal-fired power plants. And I think that's the same kind of transition we can use here to get the majority of our workers in the power plants. And then as Clayton said, though, there's going to be those, the nuclear engineers, the training programs are going to have to be developed in the universities. And actually, University of Wisconsin here in Madison has a very strong nuclear engineering program. So I think that's a bonus for us here in the Midwest, or I think we will have a very strong opportunity. Right now, staff is just hard in general, though, to get, right? It's folks didn't really come back after the COVID and the pandemic. I think we're all struggling to find good staff. So again, it's really, if we do this smart, we do it well, we do it with the transition of the traditional power plants as those age out and we need to replace them. If we do that transition right, we'll have the workforce we need right there.
Great. All right, so last question, and I think we've covered this some, but I'll send it to you first, Ben, and then Clayton will give you the last word. Where would you say the market is now with regards to SMRs and the role that they're actually playing on our grid in the midterm? And I'll let you define midterm. What sort of impact do you believe they'll be playing?
I think they have a strong role here, specifically and especially in the Midwest. We don't have the hydro resources of the Pacific Northwest. We were really heavily reliant on coal here in the Midwest. We don't have the natural gas pipeline network like they probably do on the East Coast and farther to the south. So we need that technology, that fuel source that's really going to provide that baseload firm energy for the days the sun's not shining, the wind's not blowing. And there are days and even weeks here in the Midwest where we don't see a lot of sun. It's pretty calm, especially when you get to summer peak. It's hot, humid, wind's not blowing. So while storage, batteries are going to be a nice resource, we still need something that's going to be there and really providing the resiliency and the reliability. And that's where we see SMRs coming in. Obviously, in the Midwest here, we don't have any operating now. So when you talk about the market, it's more of that midterm. It's that, what are we going to have to replace the aging coal plants, some of the big nuclear that's going to be going off? What do we have to replace it in the 10 to 15 year time frame? And that's where we're looking at NuScale and SMR technology.
Great, Ben. Clayton, to you. Where are SMRs now? Where do you see them having an impact in the midterm?
Well, I mean, to Ben's point, I mean, there's a bunch of factors. Timing is critical. I mean, we have the cliff, or what's known as the cliff in the existing fleet, where they start going off. I mean, we've mitigated some of that by extension on extending the life. But having said that, you've got 150 plus coal plants that need to be considered to repurpose. If you look at NEI's numbers and research, I mean, I think they're anticipating something of a need of 300 gigawatts by 2050 to that effect of new nuclear. So between that, plus there's things we haven't touched on. A lot of industries like the steel industry have made commitments to their customers to be green steel, so they need to look at how do they do that. A lot of the utilities are getting demands from their customers saying, we want to make sure that your power is green. If you're not giving it to us, we'll go somewhere else. So everybody has a green conscience, and they're putting targets at 2040, 2050. The other thing we haven't even touched on is the fact the whole discussion around pink hydrogen or hydrogen with nuclear power. I mean, we're getting a tremendous amount of interest from the oil and gas industry and the industrials around hydrogen production. So, they basically want clean hydrogen. So I think there's no way we can supply the demand that we see. If you look at the data centers, if you take, for example, in Virginia, you look at Loudoun County, the amount of data centers that are coming online on a regular basis. I can't remember the number, but somebody was telling me every time you do a search on your phone, it's a tremendous amount of power usage, and that's all coming from data centers. So, the energy needs aren't going away; they're increasing. We need clean, we need base load, we need clean hydrogen. It's got to be part of it, and I think people need to get over the historical. The quote unquote dark tag around nuclear. And I think everybody needs to look at nuclear now as, what it's going to take to save the planet, not change the planet.
Ben Porath, Clayton Scott, thank you so much for being with us to explore this exciting topic of small modular reactors and sharing your thoughts with us and our community.
You're welcome. Thank you.
Take care.
Yeah, thank you.
Thanks for listening to this episode of Grid Forward Chats. If you're interested in Grid Forward membership and our work to accelerate grid modernization and energy innovation, including the backlog of our podcast, visit us at gridforward.org. If you like the podcast, please share it with your friends and colleagues and give us a rating on your favorite podcast app. This session is supported by Virtual Peaker. Thanks for your support to make Grid Forward's chats possible.